some review. Some stuff is going to be review. And then we're kind of going into newer territory. Okay. I don't know if you got this, but there's 200 million germs in a sneeze droplet. Hand sanitizers kill 99.99% of germs. So this person is like, okay, if there's 200 million germs, multiply it by 0.01%. What's 0.01% as a decimal? Yeah. You move the decimal over 2 spots, right? So there should be 3 zeros. So how many germs are still alive? Anybody do the math? 20,000 or something like that? Is that the right number of zeros? One too many? Right? 200 and then another 0 there times 0.0001. So there's still 20,000 germs. I don't know how scientifically correct that is, but I just thought that was pretty funny, right? So that's why the person says ew, right? Anybody watch Dumb and Dumber? Is that still a thing? You guys, have you ever watched the movie Dumb and Dumber? It's probably a bit old. Some of you might have watched it, but there's this one scene, right, where this guy, like, they travel like across all the U.S. trying to get the luggage back for this lady. And they fall in love with her, of course, or they like her. And so he's like, just tell me, is there a chance that you and I can end up together, right? And she says, I would say it's more like 1 out of 1,000,000. And he's like, yes, that means I have a chance, right? So if you want to watch that scene, just scan that QR code. And I'm not promoting the movie. I'm just saying that's a pretty funny scene, right? Not understanding the probabilities make us make poor decisions. In fact, there's a guy, I forget his name, but he's known as the mathematician. Have you ever heard of him? Mathematician? He's faster. He can crunch numbers faster than a calculator can. Look him up. He says people should know probability and statistics, because if you understood those two, you would make wiser decisions. Right? If you knew the chances of something happening, you would make smart decisions. Like, for example, if you buy a toaster from Walmart, I don't know if you ever bought any electronics from Walmart. What do they normally ask you at checkout? Yeah, would you like to add warranty for, I don't know, $5 or whatever? And you know how many people say yes to that? Because they're like, hey, then it's like you're talking a $30 toaster, right? What are the chances that it breaks? And if it breaks, I'll just come back and buy another toaster. But my chances are pretty good, right? My toaster isn't going to break, most likely not going to break. So I'm going to pass on that, right? In fact, when I go to the Brick and buy a washer and dryer, if I buy anything, I don't get the warranty. I don't get it. And they might tell you, oh, if this breaks, right, this right here costs $500 to replace. I'm like, well, I'll take the chances, I like living on the edge, so I'll just go with it. I don't buy it because they know, right? They make money with that insurance because they know you're probably not going to come back and claim it, right? They know that, right? So they know their probability. You should maybe ask, well, out of 100,000 washers, how many failed? How many of those failed? If they could tell you that, and the number is very high, I'd say, okay, then I'm not buying this brand. I'm buying a different brand, right? But anyways, they don't tell us that. So anyways, probability can be stated in 4 ways, guys. Make sure you understand that. Expressing probability is very important. You got your calculator because you think you don't need it, you need it, okay? This is what I want you to remember. There's always 3 ways you can represent it, right? Words is the easiest one. Let's do that one. 1 out of 3, okay? 1 out of 3, I go by the fraction normally. But watch what I want you to do in this unit to get this right, to not lose rounding marks. 1 divided by 3, this is what shows up on my calculator. Right? That's what shows up on my calculator. I don't want you to necessarily write that down right away. Okay, I want you to say, okay, this is on my calculator. If I want to state it as a decimal, I'm going to go 0.33, right? I'm going to state it to 2 decimals. What would this be as a percentage? Most students would say, well, it's 33%. Obviously, no. You go back to the calculator, you multiply that by 100, and it's actually 33.33%. Okay? This is what it is correctly. Okay? And then the 1 out of 3 in words. When stating your answers in any format, always refer to the number on your calculator screen. Okay, so I will say this is calculator screen, right? This is what I see on my calculator. And hey, I want to state it as a decimal, no problem. I want to state it as a percentage, no problem. Words, I go back to the fraction actually. Okay, let's keep going. I'll show you another trick that I actually like. I'm going to round my decimals to 4 decimals. Watch what I'm going to do here. So 2 divided by 7. On your calculator, you see 285714, and that keeps going. Right? So my decimal, I'm going to go 1, 2, 3, 4. That's the 4th place right there. So it's 0.285. Is it 7 or 8? What is it? Look at the number right beside it. It's a 1, right? So it stays 7. Because it's not a dollar amount, you can round it to whatever you like. Except for it has to be 2 decimals minimum, right? You can do 3, 4, 5, 6 if you want, right? And percentage, I just take that number and multiply that by 100 and say, hey, it's 28.57%. You'll never lose marks if you do it that way, right? State to 4 decimals, right? I will say, hey, if you state this to 4 decimals and use that to come up with a percentage, no problem. You will get it right every time. But if you do this, can you look up on the screen 1 second? If you just put down 0.28 and say the percentage is 28%, you're going to lose half a mark, right? Because you're rounding, then you're rounding again, right? They don't want that. The province would say that's wrong. And then words, I go back to my fraction, 2 out of 7. Okay. And so you need to know how to do that. This is very popular in this unit, very, very popular. Simplifying fractions, guys, I'm going to make it optional. Got it? If it's fractions, if you need to simplify it, I'm going to make that optional, but it will always show you how to do it. I shouldn't say always. Quite often, I will show you how to reduce a fraction. But that's not an outcome for grade 12 essential. Okay. So converting, I can put money down that you're going to have this on several ACs, probably even tests and quiz, right? So you should be pretty good at filling out a chart like this. Okay, so when you have a decimal, I'm going to go to percentage, and I'm just going to multiply that by 100 to get 19.2%. Not too bad, right? How would I do this as a fraction? This is tough. This is like going back grade 8, maybe. That's why it's tough, because you don't remember. How would you state that as a fraction? Blast from the past, you ready? Ready for this? How many decimals does it have, that number? 3 decimals, right? So you go 1, 2, 3. you add 3 zeros to the denominator, because the first one is your tens, right? Your hundreds, your thousands, right? So right now you have 192, 192 thousands. That's what you have. Oh my goodness, I totally remember that. And I have nightmares at the same time because I remember grade 8. Right? No, you don't. So that is, I'm just going to leave it like that. I know you can reduce it, but I'm just going to leave it like that for now. Okay. So how should I do this for your notes? I don't know. 3 zeros, 3 decimals. Right? Therefore, 3 zeros. I don't know. Does that make sense? Hopefully. 3 decimals, 3 zeros. So on they go. On right underneath here, 3 zeros. Okay. Next, this one. To get from a percentage to a decimal, what do I do? Divide by 100. That's right. And some of you will just shift the decimal, right? So this is 0.3575. Do not round there. Just write down the whole thing. Got it. And now, how many zeros? 1, 2, 3, 4, right? So you go 1, 2, 3, 4, and write the whole thing as your numerator. Okay? 4 decimals. 4 zeros. Okay. Take a second or two to fill in the 2 rows there. Maybe you did it already. You should be able to do that. I don't know. There we go. So decimal, I'm going to state it. Ooh, 0.5 or 0.6? 0.6. There we go. And so that times 100 would give me 78.06%. So you round once, and then you don't need to round again if you do the 4 decimal method. 0.1234. 4 zeros like that, and that'll be 12.34%. Done. Hopefully you got that part. Okay, keep going. Simplifying fractions. Dun, 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 dun. You ready for this? Some of you. You know what? I think a lot of those skills that are taught in the younger grades should be taught when you're older, because then you're ready for it. But anyways, the easiest way is to divide, watch this, both numerator and denominator by the same value. You keep doing this until you cannot find a common factor anymore. The fraction is then called simplified. Okay? Watch this, some rules here. Hopefully you remember them for the rest of your life. If the number ends in an even number, the whole number is even. So it's divisible by 2, right? If a number ends in 0, it's divisible by 5 and 10. There we go. Thank you. If a number ends in 5, then it's divisible by 5, right? If the sum of the, this is a different one. I don't know if you remember this one. If the sum of the digits is divisible by 3, then the whole number is divisible by 3. Did you know that? It's a quick little check. You add up the numbers that make up that number. So can I divide that number by 3? Yes. Okay, then the whole number can be divided by 3. It's a cool little. Okay, so watch how I do this. I might be doing it differently than what you're used to, because your teachers may have told you to find the biggest common factor. I don't necessarily do that. Even, correct? So I'm going to go divided by 2, divided by 2. So half of 28 is 14. Half of 42 is 21, right? Are they both even? Not anymore. So I can't divide by 2. 7. There we go. So now I needed to go a little higher, right? So divide both by 7. And so that'd be 2 over 3. And let's say you're not sure if you did things right. This is how you check. You take the original one, 28. 28 divided by 42 is 0.66 repeated, right? This one. You better get the same answer if you take your reduced fraction, and you should be able to get the same outcome. If you don't, you did something wrong, okay? I feel like I want to give you a bit of a go here. So try it. I did smaller numbers first, and then I go a little bit bigger. This is as crazy as it's going to get when it comes to reducing. Nothing bigger than this, okay? So if I ask you to reduce at all, it's going to be very doable. Okay, so go for it. You use your method. That's why I give you lots of space there. You reduce it. I will do it silently up front, so if you want to check, you do it. I'm done there, right? What did I do there for this one? I added up the digits. 8 and 4 gave me 12. 2, 1, and 3 add up to 6. Both of them are divisible by 3, so I go ahead and divide them both by 3. Okay. And that'll be 2, 28, 7, 1. There we go. And that's it. Both even. Can I? This is 375. Yes, but I made a mistake here. I wrote 325 instead of 375. So I was stuck. Yeah, divide this by 3, that's right. Because this adds up to 15, this adds up to 12. Yeah. So 22 over 125. There we go. That's it. Okay. Let's keep going with the actual probability portion of today. Deck of cards. Deck of cards is very important, right? I need you to have a very small way on your study sheet to refer to a deck of cards. So I'm going to help you out with that. I don't want you to have the whole thing on your study sheet. It's going to take up way too much room. But remember, in general, when a question talks about a standard deck of cards, that does not include the jokers. So we have, watch here, 52 cards in total. Half of them, this is your line here, half of them are red, 26, and 26 are black, right? And then you have your 4 suits, right? Clubs, spades, hearts, and diamonds, and there's 13 of each. 4 times 13 gives you 52. There are what we call 12 face cards, guys. 12 face cards. So the jack, queen, and king, right? There's 3 in every suit. Make sure you pay attention, okay? 4 times 3 is 12. So these here will be considered our face cards. Watch this here. From 2 all the way to 10, this would be considered our numbered cards. So 2 all the way to 10, those are called numbered. And then you have your aces, right? You have 4 aces. That is not considered a numbered card. 4 aces, can we say that? 4 aces. And I'll give you a short version of the deck of cards. I think you're going to like it. So you have your diamonds and your hearts, right? Spades and clubs, okay? So for example, if I said, listen carefully, if I said, what's the probability of getting an 8? I'm actually talking about all 4 8s, right? What's the probability of getting a red 8? Then it's just, there's just 2 of them, right? What's the probability of getting an 8 of diamonds? How many 8 of diamonds are there? Just 1, right? So watch it. A red face card, how many red face cards? These are all reds, right? So there's only 6 red face cards. So I'm going to draw from it quite often. So here we go. You ready for the shortcut? 52 cards, and it splits up to 26 black, 26 red, like that. And then you have your 13 clubs, 13 spades, and you have your 13 hearts and your 13 diamonds. Okay? You can make it even smaller if you'd like. And if you need this, I don't know if you need this part that's coming now. Every single one of them has an ace, numbers 2 to 10, and then a jack, queen, king. Every single one. Ace, 2 to 10, jack, queen, king. Ace, 2 to 10, jack, queen, king. Okay. So that's basically what it breaks up as. And I don't know if you want to go, these are my face cards. You want to circle these here, circle these and say, hey, these are my face cards. You do whatever you need to do, right? I don't know how much you need. That's why I give you a full-on deck of cards picture so you can visualize it and then you go with it, okay? So you're gonna need to know your deck of cards. And now we're gonna start probability, which isn't gonna be brand new. I know that. You've seen probability before, but just make sure you don't think, oh, I got this, I'm just gonna tune out, because you're gonna be surprised how much you need to know down the road. So this is your deck of cards. You can probably make it smaller. I know some of you here can make it fit on my thumb, right? But that's your job to make that work. Maybe you don't even need it. I don't know. You play cards all the time. You don't need it, right? That's fine. Okay, let's go. Page 5. Probability. The probability is the likelihood of an event happening. Usually we state it as a fraction. At the very beginning, almost guaranteed I will use fractions first, and then I'll turn it into decimal and percentage if I need to. So the probability of an event is the number of favorable outcomes. Like these are the outcomes that we're looking for over, watch this, total possible outcomes. Go ahead. So one thing I need you to remember, guys. I need you to remember this. Think of a pie chart, right? And that would be 100%. There's 100% likelihood of something happening, right? Or that's our total possible that we can get. If something is 100%, like if it's going to snow, if the probability of snow is 100%, it is going to happen. There's no chance that it's not happening. But as soon as you, if someone were to say, hey, there's a 25% chance of it snowing, what do you know as well? What would the 75% stand for? Not snowing. That's right. All right. So there's always the probability of something happening and something not happening. Very, very important concept in probability. There's no such thing as 120% chance of something happening. There's only 100. You can have more than 100% when it's like something increased by more than 100%. You can have that, but in probability, you cannot have that. Okay. Key concept to remember, therefore, probability of event happening, that's P of event, plus the probability of the event not happening, E bar. See that bar on top? That's not in math. Is 100% or 1. So if we're not talking percentages, just decimals, it would turn out to be 1, right? And watch, E bar or E, see a little apostrophe there? That just means against or not, okay? Not. Okay. Therefore, just follow me here for a bit before we do the math, okay? Therefore, if you know one of the probabilities, you can find out the other, just like the pie chart I showed you earlier. If the probability of the event happening would be 1 minus the probability of the event not happening, or probability of event not happening, you just take 1 or 100% minus the probability of the event happening. So both of these are true, and they come from this big one here. Okay. A fair game, watch this is important. A fair game has a probability of 50%. If there's a 0% chance of something happening, we would consider it impossible. If there's 100% of something happening, then it's certain. It's certain. Okay. I will ask you, I will give you some odds later on, and I'll tell you Jets, the odds of the Jets winning a Stanley Cup are these. The odds of the Boston Bruins would be so and so. Which team has a bigger likelihood of winning? It's always the percentage that we go by. Okay. Okay, total is provided here. This is an example. There are 20 students. This is your total in Mr. D's class. He knows that 7 of those students drive a car to school. Okay, 7 of the students drive a car to school. A, state the probability of a random student driving to school. By the way, it has to be random or else it's not true probability. Probability of someone driving I write it like that, then we know what we're finding. You know it would be 20 here. Total possible outcomes. There's 20 students to pick from, and 7 of those would be driving. That turns out to be, if you use your calculator, right, 7 divided by 20, that's 0.35, separated by a comma. Okay, this, comma, that, or this doesn't have any more decimals, it's fixed, right? So you just multiply that by 100 and state 35%. Therefore, probability of not driving, make sure you write this down the way I do it, right? Not driving, what would it be? How many students would not be driving? A 7 out of 20 drive. Can I show it? 13, right? Can I show it like this? I'm going to go 20 minus 7 over 20. So 20 minus 7 is 13 out of 20, which is, can anybody guess what the decimal will be just by looking at the top here? 0.65 or 65%. Notice that event happening and not happening adds up to 100%. Trust me, it gets more complicated than that. So just for now, just follow along, write it down. You'll be fine. We're good? Next page. Page 6. This is where the total needs to be determined. Consider the spinner below. Spinners are very popular as well. State the following in these 3 formats. What's my total here? How many total outcomes are there? That's right. Total outcomes. What's happening here? Total outcomes. 8. There's 8 sections. 1, 2, 3, 4, and another 4. So this is very important. So what's the probability of the spinner landing on a red section? Is 1, 2, 3, right? 3 out of 8. If you divide that, you get 0.375. It stops, right? So I'm going to use all those decimals. And I'm going to take that, multiply it by 100 to get my percentage. Okay? I think you know enough now to do the rest. I'm gonna leave you, give you a bit of time. You see the weird one down here, watch. Probability of it landing on green or yellow. That means that you can add them. It's almost like consider all of them as your pros. But for now, just do the rest. See if you can do that. Give it a go, and I'll be right back. I want to get to the cards actually. Probability of landing on yellow. There's only one yellow section. I was about to print it without writing in the colors, and then I was like, wait a minute, that's not going to work. So anyways, yellow, it's 1 out of 8. That would be 0.125, which is 12.5% chance of that happening. Probability of blue, there are 2 blue sections there. So that would be 2 out of 8. Come on, you can do a quarter, right? That's 0.25, 25%. Watch this one, how I do it. Okay, probability of not yellow. So I'm going to go 8 minus 1. I'm going to take away the yellow. So that gives me 7 out of 8, which is 0.875, which is 87.5%. So the probability of it not landing on yellow is pretty high, right? There's only one yellow section. Not landing on red, I'm going to take 8 it's easier to count how many reds there are and take it away. Because imagine you have a lot more sections, right? Then it's easier to just take away. So that'd be 5 out of 8. And that would be, I have it here, 0.625, which is 62.5%. Okay. Green or yellow, what do you do with an or? Yeah, you add them. So how many greens are there? I counted 2, right? So 2 greens and 1 yellow out of 8. So that's 3 over 8. And I believe we have 3 over 8 at the very beginning. So that's what it is. So or is just added up. Just add it up. Blue or red. I counted 2 blues and 3 reds out of 8. So that's 5 over 8. And that is, there's a 5 over 8 already, yeah? Yeah. 62.5%. Okay, there we go. Let's see if you get this one. What if I asked you probability green or yellow, but I did this? You should be able to answer that based on what I've been saying today. This is probability of green or yellow, correct? This is not happening, that not happening. Snow, no snow, remember? So we could say, I'm running out of room here. I'm going to go like this, 100 minus 37.5%. Okay, can I do that? What is that? 62.5, right? Percent. So this is what I'm after there. I took away it happening. Can we handle that on a morning? Thursday morning? A gloomy morning? Anyways, keep going. I'm moving on. Making predictions. So we can use probability to predict things on a larger scale. Did you know that all surveys, like when they come up with who's going to win the election, do you think they ask every single person in the country? City, not even Sisler. If we were to have a student council who wanted to vote, I don't think you would ask everyone. You would grab a bunch of people, random as possible, and just ask them and then say, hey, 25% of these people are voting for that candidate, so we can kind of just predict it on a larger scale. This is what's happening there. When we state a probability, we can use it to make a prediction. Do you remember that word extrapolating? Have you ever heard it? Maybe. Extrapolating is going beyond the data you can see. All right? It will never show up again. It just shows up here. I just thought I'd teach you a new word. Or forecasting, right? You're forecasting, you're extrapolating. I will put money down that after today, you're going to hear this word at least one more time in your life. I can guarantee you that. You've heard it before, but you just kind of blocked it because you didn't know what it meant, right? Prediction is probability of event times the greater sample size. This should be on your study sheet. So watch this. If you were to spin the spinner above 350 times, how many times would it land on yellow? So we go like this, prediction. We're going to go probability of yellow times sample, greater sample, that is. What's the probability of it landing on yellow? Let's go up there and check. 1 out of 8, right? And we're going to multiply it by 350 spins. So we're saying, hey, if we were to spin it 8 times, it would land on yellow once. So let's see what happens when we do 350 spins, okay? So here we go. You take your calculator, you go 1 divided by 8 equals times 350. That's 43.75. We can't have that, right? So we would say approximately 44 times. or 43. I would accept either one because some would argue, well, let's be conservative and say 43. Let's not go for the 44th. It's fine. The province is okay with that as long as you have a whole number. If the wheel was spun 199 times, how many times would it land on red? Right? So you're making a prediction. You're going to go probability of red times the sample, the greater sample, that is. And let's go up there and check. Probability of red is 3 out of 8. And we're spinning it 199 times. 3 divided by 8, you're with me, right? 74.625. I'm going to write down the whole thing, but then just go, right, like a wavy line like that. We'll go 75 times. Approximately 75 times. So that's what we're predicting. Do you think that's actually going to happen? You might be off, but in theory, you'll be pretty close to that. So maybe that's your homework. Take a spinner and just spin it 199 times, right? Right? You're with me? Not going to happen, Mr. Dirksen. I have way better things to do. I'll just believe you. I just trust you. Keep going. I want to go to page 8. I'm going to let you do page 7 in a bit. That's going to be part of my assignment to you. Consider a standard deck of cards. State the probability of drawing a 5. So, you know your deck of cards, right? I went and robbed the casino, right? The decks, did you know that? The decks they don't use, they just punch a hole through it. So you can't reuse them, right? So anyways, what's the probability of drawing a 5? So you go like this. Probability of 5. How many cards are there? 52, that's right, thank you. How many 5s are there? 5. No. How many 5s are there? 4. Okay. I tried to trick you into 5. Can we reduce this? Divide them both by 4. That's 1 over 13. Comma. It's okay if you just want to stick with 4 over 52. That's 0 point, watch this. Can you do this part? Can you round that? 0, 7, 6. Oof, I don't know. I'm just going to gamble on that one. It's 9 because the 2 doesn't affect the 9. So that's what you write down. You multiply. I leave it on my calculator if you're not sure. Multiply that by 100. So there's 7.69%. So you stated it in 3 formats. Okay. The province, I'm not kidding you. Every once in a while they have questions in there that are so easy. Students are like, nah, this can't be. This is like, leave it blank. But they have asked in the past, they're like, hey, 4 out of 52, what is that as a percent? 1 mark. The whole page, 1 full page, just for that one question, right? So yeah, you need to be able to turn this into a percentage, right? State the probability of drawing a face card. Probability of face. Again, it's deck of cards, so the total number of outcomes is 52. How many face cards? Anybody? 12. Red face cards? 6. Black face cards? 6. Okay, so just read carefully. I'm just gonna leave it like I feel like simplifying. Okay, so even. So 6, 26. Keep going. Even, right? 3, 26 divided by 2. You see a pattern with cards. to be honest, especially the denominator. You see a lot of 13s, a lot of 26, right? So that's what it is. 12 divided by 52. Why do I not use this? Because I may have made a mistake. So I go back to the original. I divide that. I get 23.0. Help me out. 7 or 8? The 6, right? If it's a 5 or more, it bumps it to an 8. So that's 23.08. I think by the time you graduate grade 12, you should be able to do that. So when you cross the stage and you get your diploma, I'm going to stand at the end. I'm going to be like, round this. Okay, now you can graduate. Move on. All right, state the probability of drawing a numbered card. A numbered card. So 2 to 10, right? You need to do a little bit of thinking here. Probability of numbered. Can I say something else here? Not a face card, but what also not? Or ace, yes. No face cards or aces, right? That's what it's actually saying. So 2, 3, 4. I would have a somewhat of a difficult time to do that in my head right now. How many numbered cards are there? Anybody? Couple ways to do it. This is one way of doing it. 52 cards, right? Take away the faces, take away the aces, right? So this is what? This is 40 minus 4 is 36 numbered. You see what I did there? I hope so, right? So I took away faces, I took away aces. That's kind of funny, right? Aces are just faces without an F. And so 36. So this is what I'm after. So 36 over 52. I don't feel like simplifying it. You don't have that choice if I ask you to do it, okay? So that's how I roll. Do as I say, not as I do, right? 3.692. You want to graduate or what? 2, 3. 3, right? Because the 0 keeps it. That's 69.23%. Okay. I feel like I've talked too much already. I'm just going to say, do everything from pages 7 to 10 that I haven't done with you. Okay, so homework. And make sure you try it, right? Like it's right now, if you stay on top of it, you'll be okay, right? The problem is if you it's like, I kind of sort of get this, I remember this, right? But just make sure you get it, right? Make sure you know it. And then I will post the keys to 7 to 10 once we're done here. Can I just say one thing? I noticed that go to G on page 8 that we're on. You see that weird state P8? You see that little bar on top? Or is that, it's hard to see, right? It's basically saying P not drawing an 8. That's basically what that is saying. 8, anything with a bar on top, just assume that it's saying not that. Not, we don't want that. We don't want to draw an 8. We want to draw everything else, but not an 8. Okay? Okay, that's it, guys. Thank you.